we want to evaluate the integrals by interpreting it in terms of area, where we can model a def integral as the area bounded by the function on the x-axis as long as we recognize that the area above the x-axis would have a positive value and the area below the x-axis would have a negative value. So looking at the graph of f of x, notice on the interval from 0 to 2, the area is above the x-axis, so the def integral would be positive over this interval. But notice on the interval from 2 to 4, the area is below the x-axis, and therefore the value of the def integral would be negative over this interval. And then on the interval from 4 to 5, the area is above the x-axis again, and therefore the def integral would be positive over this interval. So for our first example, we have the def integral of f of x plus 3 from 0 to 4. So for the first step, we'll write this as two separate definite integrals, where we'd have the definite integral of f of x from 0 to 4 plus the definite integral of the constant function 3 on the interval from 0 to 4. This is the reason why I also included the graph of the constant function y equals 3. Let's consider the integral of f of x first from 0 to 4, which should be over this interval here. We'll notice on the interval from 0 to 2, because the area is above the x-axis, the value would be positive 2. So here we'd have positive 2. But then on the interval from 2 to 4, the area is below the x-axis, so the value of the def integral would be negative 5, since this area is 5. So we can say 2 plus negative 5, or just 2 minus 5, plus the integral of 3 on the interval from 0 to 4. Well, again, the function y equals 3 is the horizontal line given here. So over the interval from 0 to 4, notice how the area is above the x-axis, and the area is also just a rectangle. So we can determine this area. The rectangle would be a 4 by 3 rectangle, and therefore the area is equal to 12. And because it's above the x-axis, we know the def integral over this interval would be positive. So we have plus 12. Well, this would be negative 3 plus 12, which is equal to positive 9. Let's take a look at a second example. Now we have the integral of f of x plus 3 from 0 to 5. Again, for the first step, let's write this as two separate integrals. We have the integral of f of x from 0 to 5 plus the integral of 3 from 0 to 5. So looking at our graph of f of x, notice from 0 to 2, the value would be positive 2. But then from 2 to 4, the value would be negative 5 because the area is below the x-axis. So again, we can write plus negative 5 or just minus 5. But then from 4 to 5, because the area is above the x-axis, the integral would have a value of positive 2, so plus 2. And then finally, plus the integral of 3 from 0 to 5. Again, here's a graph of the constant function y equals 3. The area is above the x-axis, so we know it's going to be positive. And because the rectangle here is a 5 by 3 rectangle, we know that the area is equal to 3 times 5 or 15. And therefore we have plus 15. So here we have 2 minus 5 plus 2. That's going to be negative 1 plus 15 equals positive 14. I hope you found this helpful.